Not done.
So actually, we're starting a new unit today, guys. Guys, we're starting a new unit today about functions. I don't know if some of you guys have learned about functions in the past, but Common Core treats it a little bit differently. And what I tell people is, I think of a function as what's called a number conditioner. You know what an air conditioner is, right? No? Wow. Think of an air conditioner. What does the air conditioner do? It sucks in what?
Hot air.
What kind of air? Hot air. And it cools it down and spits out cold air, right? So the input is hot air. It takes in hot air, it does something to it, and then spits out as the output cold air, right? So instead of an air conditioner, I tend to think of functions as number conditioners, meaning it takes a number in, it does something to the number, and then it spits out some other number, okay? Got the idea? Let's look at the examples here that I gave you. So the first one, I said you put a 3 in, and you get a 3 out. You put an 8 in, you get an 8 out. You put a -5 in, you get a -5 out. You put a 4 in, you get a blank out. Khalil, sit over here for me. Yes, you can. I trust you.
I trust you, trust me again. So give me one more chance, please.
All right, if I hear you one more time, that's it. So, you put a 3 in, you get a 3 out. What's happening?
Adding 0.
Adding 0, good. That's one possibility. What if I told you it was doing something with multiplication?
Times 0.
Times 1, that would work too. Good. You could say it's either adding or subtracting 0, or it's either multiplying or dividing by 1. All of those would work, right? We don't know which one it is, but it's one of those. So what would we put in for here? You put a 4 in, what comes out?
4.
Good. Got the idea? So if you by examining the inputs and the outputs, we can figure out what the rule is, okay? Every function has a rule. That's what it's doing to the number once it comes in, okay? All right, let's look at the second one. They get a little tougher as we move on here. I mean, nothing really crazy. So you put a -2 in, and you get a +2 out. You put a 5 in, you get a 5 out. You put a -7 in, you get a +7 out. You put a 3 in, you get a blank out.
That's mad confusing.
Well, think about it. What's it doing each time? A -2 comes in, a +2 comes out.
And then the +5 comes out and the +5.
Right. You put a +5 in, and a +5 comes out. So what's happening? What's the rule you can think of that's going on here inside our function? A -2 becomes a +2. A +5 stays a +5. -7 becomes a +7. A +3 would come out as a what?
+3.
All right, so what's going on here?
Adding 0.
Adding 0? No. Because what's -2 plus 0? That would be 0, -2, right?
That was bad, Lord.
So a -2 becomes a 2. What's happening?
Multiplying.
No.
I don't know.
Well, just in words, tell me what's happening. The -2 becomes a positive.
You gotta add 4 for that.
Say again?
Don't you add 4? If you add
For that one, yeah. You could say -2 plus 4 is +2, but does that work for this? What's 5 plus 4? That would have to be 9. Yeah, so it's not good enough to get a rule that works with one set of input. It has to work with all of them, okay? Look, a -7 becomes a +7. What's it doing? In English words, what is it doing?
Switch to the side.
Huh?
Switch to the side.
It's getting rid of the negative sign, right? If it's already a positive, what's it doing to it?
It's staying a positive.
It's staying a positive. Does anybody remember a function in math that does that? If it's a negative, it becomes a positive. If it's a positive, it just stays the same? No? Remember this thing?
Is that?
You never saw it? Absolute value?
Oh,
Yeah.
That's what absolute value does.
Doesn't that keep
why you ain't do that?
positive?
If it's a positive number, it doesn't do anything. It just gives you back the number. If it's a negative, it strips away the negative.
Oh.
It just takes the negative and gives you the positive version of it.
Why does it get so simple after you say that?
I don't know. By the way, so this is what you write for the rule for the second one. Let me go back. I didn't actually write the rule for the first one because we want to write it using an x. So for the first one, it would have been like x plus 0 or x times 1. Okay, whichever one you want to use. Okay. Can I go to the next one? I'm collecting this paper, by the way.
This one's easy.
All right.
Well, not yet.
No, well, you're right. I mean, they get easier.
I didn't think it was.
Oh, I mean, they get harder. What am I talking about? They get a little tougher.
I didn't think it was easy 2 minutes ago.
Number 3, okay. Number 3, you put a 2 in and you get a 3 out. You put a 9 in, you get a 10 out. You put a negative 3 in, you get a negative 2 out. You put a blank in and you get a 6 out. So what's happening? What is the function doing here? What's the function? Plus 1, good. What end up, huh? I do.
It's so good, Mr. King.
What?
Yeah.
Oh, you don't need it? Do you have it? Okay. All right, so Elijah said plus 1. Whatever you put into it, it's adding 1 to it and spitting it out. So the rule would be x plus 1.
Yeah, you did
What's that?
3.
No, you sure, right?
I gave you the wrong book.
So,
That's it?
This is x plus 1.
You know, I thought it was the wrong book when I took it to it, but I was like, oh, this one.
no one will take you out.
No.
Well, do whatever's in there. I must have left the coin.
Oh, like,
All right.
It's x plus 1.
Yeah, whatever number you put in, it's adding 1 to it, right? 2 plus 1 is 3. 9 plus 1 is 10. Negative 3 plus 1 is negative 2. So what number goes here? Good. All right. Khalil.
Nah, but you said
Yeah.
why you was talking.
No. Oh. Yeah, well, I hope you write it down. I don't know why you haven't done that before.
That shit back there worse.
I gave it to you 3 times already.
So I had it on a piece of paper. That's what happened. I pulled it up. You gotta put in my wallet.
I mean, look, yo, that's what
Let me get to a certain point. Let me get to a certain point and then I'll find it.
Oh, my stomach hurt.
All right.
We got.
Let's go to the next one.
I'm like, I already know, like, hey, that shit fucking me up, bro.
All right, number 4. You put a 1 in, and you get a 2 out. You put a 3 in, you get a 6 out. You put a negative 4 in, you get a negative 8 out. You put a 7 in, you get a blank out. Times 2, good. How do I write that with an x?
2x.
2x, very good. And what would the last one be here? What's the blank? 14, right? 7 times 2 is 14. Right? So the rule in this case would be multiplies the input times 2. So far, so good? All right. There's only like what? 2 more? All right. You put a 2 in, you get a 7 out. You put a 7 in, you get a 22 out.
Oh, yeah.
You put a -4 in, you get a -11 out. And I forgot to do the other one. What's happening here? What's the rule going to be? What do you do to a 2 to turn it into a 7? Or what do you do to a 7 to turn it into a 22?
For 2, you add 5.
Times 3 plus 1.
Ooh, yeah. Multiply the input times 3 and then add 1. 2 times 3 is 6, 6 plus 1 is 7. 7 times 3 is 21, 21 plus 1 is 22. -4 times 3 is -12, -12 plus 1 is -11. Good. So 3x plus 1. Nice work. Everybody got that? All right, last one.
That's times itself.
Oh, before I even got there. Okay, good. Let me just do it for everybody. You put a 3 in, you get a 9 out. You put a 6 in, you get a 36 out. You put a -5 in, you get a 25 out. Right, as Savia said, this is going to be, it's the number that's input times itself. How do I write that? If the input is an x, how do we write it?
Oh.
I could write x times x, but what's
X
the
squared.
x squared? Good, there you go.
Yo, Mr. Keegan, what's the rule? Like, can you explain to me what I'm supposed to write for a rule?
The rule is you could just write this, okay? Just
I
write
want-
x squared. Yeah, whatever I was writing here is what the rule is. In this case, the x is your input. Okay, the input's always x,
Oh,
the
you
output's
already
always
on the
y.
last one?
Huh?
You already on the last one?
I did. The last one was 3x plus 1.
So how about 4 and 5?
Times is 3x plus 1.
Okay? So if this number here was 4, what would this number have to be? Huh? 2 or what? There was actually another one you could use. -2, good. Because when you square a negative number, it becomes positive. All right, good. Let's actually, let me collect this sheet though.
Yo, what was the number for number 5 though? You know, I got the play. But Mr. Keegan, I didn't even know you was doing that. I was looking at it myself trying to get
I know, but I told you I was collecting the paper.
Yeah. But what's number 5? The blank.
Number 5 is 3x plus 1. Oh,
No,
the blank.
yeah,
No,
the
forget
blank.
the blank. I forgot to, I should have put something in. Don't worry about the blank.
Oh, I've been filling those.
The last 2, I didn't put the blank in, so don't worry about it. Okay? I kind of put one on the screen, but you don't have to worry about it.
Nah, I've been filling those in. That's
Well,
why I
up,
get
for the first 4, you're supposed to fill them in. That's okay. But the last one,
Oh.
I forgot to put something
So
in.
it's number 4 tonight. That's 2x.
Oh, look. So this says it takes this number, the x, and it multiplies it by 2. What's 7 times 2?
Oh, I thought that, but I wasn't sure. Like,
Mr. King, how
And
much
this
is now?
one is x plus 1.
X plus 1. Nah, how's the X plus 1? Oh, but
2 plus 1 is 3, 9 plus 1 is right? Okay?
Yeah.
And this one was absolute value of x. Remember the 2 vertical lines with the x in the middle.
Yeah, oh.
Just write it down.
Okay, I'm tired. Thanks, Mr. Keegan.
You're welcome.
Mr. King, help me?
Oh, yeah, shut up.
Oh, right.
It's showing brothers and
I don't know.
This one?
I know how to
Yes,
solve it, but I
that's
don't
right.
know.
Good.
It says connect the line.
All right.
And then write the letter.
You better be careful you don't take off like a helicopter. I'm gonna have to grab your sneakers.
What?
That's the
Let me just stop.
That's it, we'll do 2 lines. That's it, we'll do 2 circles. And whatever you get, that's it.
All right, peoples.
So 1,
If I can call you peoples.
2,
That wouldn't make sense.
We're going to write stuff. You know what? Let me leave this here.
You have to put it to the answer.
Yeah, oh shit.
So you got like say
Um,
something with this, right?
Does everybody else have their little white notebook? I'm gonna find yours. Khalil, I'm gonna find yours. I want you to write these two things down in your white notebook though.
Shit.
The first thing is a definition of function, and the second one is a definition of how the rule can be given. I just want you to write it down.
Well, like, I just need a reason. Hey.
It's gonna be something. I'm not gonna say that.
Why you even do it?
Huh?
Why you even do it?
Get out of here. Get out of here.
Mister, can I get scrap paper?
Yep. I saw I saw a lot of the last quarter on it. We should have won the game. I got robbed. It's amazing how they always play them good.
I heard they paid you 2 days from shooting.
I think they paid you, bro.
I heard they got you a pound for that extra pound for a pound.
Write down the stuff on the board. Justice, in your white notebook, write the definitions down.
Mister, can you back your calculator today?
How much is it worth to you?
A lot.
Really?
Calculator, same shit.
Everybody makes fun of the way I say calculator.
How you say it?
Say calculated.
Calculator.
What number is yours?
Calculated.
What is it? I don't like you.
What's up, I think I'm on.
Hey, what's the
Get
true?
that G1?
Hey, what?
That's diamonds inside.
Keegan, what does that say? A what? A what?
Actually, it's on the paper I just gave you. Look at the paper in the box. Here.
It says a early.
A clearly defined.
Oh, no.
Not a girly defined.
That's not even how you spell girl at all.
Yeah, well,
So what?
a clearly defined rule. It's also on here. Okay, it's in the box on the hand that I gave you. If you're having trouble with my
Oh,
hand.
wow. It really is.
Well, when was the last time I lied to you? The other day when I said I was happy to see you?
Nah, I think there's one before that. After that, cool.
Found Joyce. Joyce book.
Mister, how you exit this out?
Huh?
How you exit this out?
How do you do what?
I go to menu.
Yeah, go to menu. And what do you want to do? Just go up there. So Leo, I haven't found yours yet. It's just a matter of time.
Someone jack my shit.
How you doing?
Just a matter of
No, I
time.
didn't think
It was November. We
Good,
said,
good. You watching the music
It was
video?
like, nah, I need
Now you watching the music video.
You look mad at like,
You doing work.
Keegan,
who you inspired.
Keegan's not here. Can I take a message?
Yeah. come Keegan's drop.
Tell you. I can tell you. Not Kentucky. Hotel.
He
For
say, yo, do I have to?
For what?
Thanksgiving.
Yeah, I don't know. Remember,
I have
it's
10
only in there.
Yo, Mr. Keegan, what you do for second
Well,
and
I'm
sixth
gonna
period?
What do I do?
Up there. What you think?
Math?
Nah, but Common Core. Right?
Eating.
Oh, yeah, of course. It's all
Eating.
common core.
Getting drunk.
So how
Like
come
yourself?
No.
Oh, why you asking?
I'm
I
not
asked
10
you
months.
not long ago, you was like, nah,
That's ganging that
you ain't smart enough.
You
You ain't good enough.
But
Well,
gang, we
to be
didn't
He ain't
honest,
saying none of that.
I think you're, I know. But I think you're better off just taking one period at a time.
Nah, that's a that. Nah, I just didn't know it was sixth grade.
I need a fit.
That's
What
like
about
a two-period
first grade?
class.
You know?
I got no fit for things that
What if I just give you a piece of lined paper you can write it on for now, okay? Let me get some paper from
Ooh, some more to say. That looks something, right? Where you got that?
There you go, buddy. All right, everybody wrote this?
Hey, hey, put this thing out there. Getting good time listen, bro.
That's what I'm doing now.
All right, let me just get rid of this and we'll go on to the worksheet.
Hey.
Hey, look. Hey, look, I'm on the TV. Hi, Mom. Hi, Mom. All right, guys. So here, exercise 1. Consider the function rule. Multiply the input by 2 and then subtract 1 to get the output. Now, if you notice, the second thing that was on the board I told you to write down was how they give the rule. It was equation, table, graph, or words. Which one is this?
Table.
Nope. Multiply the input by 2 and then subtract
Say them
1.
again. Equation.
Graph, equation, table, and words.
That's words.
That's words. All right, now we're going to convert it from words into a table, okay? So it says you multiply the input by 2 and then subtract 1. So here, if the input is 0, we're going to multiply that times 2 and then subtract 1. What's 2 times 0?
0.
Was 0 take away 1?
0.
No, minus 1, right? So their first point is going to be 0, comma, negative 1. And then just go ahead and fill this in, right, changing the x each time.
And then you just plot it.
Then we're going to plot it, and if you plot it right, you're going to form a straight line.
Okay.
What?
Gene, why are you saving the files?
I have to bring downstairs so they can sign them. And so I get my money.
Gene, that is what I just said.
Come on, it's probably $1.23 there.
I'm sticking in.
You can take it if you want.
No, I'm alright.
So this would be a 1-to-1.
Yep.
I got 2 different answers and neither one of them is here.
For which one?
This one, I got 12 and then I got 1.5.
Okay, so you're gonna say minus 3, right? To get x divided by 8 is less than 12. To get rid of the fraction, multiply both sides by 8. So you got 8x is less than or equal to 96. Right?
Oh, and I was going to give you a calculator.
But this doesn't have 2 sides, so how would I know?
The 0 is here. Look, because there's no negative x's, they said, well, we're not even going to show you this side. So that's your origin point there, okay? There's no negative x's, so it doesn't matter. You're just going to go to the right.
So, but it's -1. Why is that?
That's the y is -1. That's okay. That means you go down 1. There's no negative x's there, though. So you're just going to go, on 0, you go down 1. When x is 0, you go down 1.
You said multiply both sides by 8, right?
Yep.
The 15 and the 8?
16.
The 15.
No. Well, first you have to get rid of the 3. Then you're going to multiply the 12 times 8. Wow. People not here today, huh? Gotta take the good ones. Are you were doing this?
I wrote down the definition.
What about this part? That's what you're supposed to be doing.
I just finished. I'm not even
Oh, okay, why?
So I'm gonna do stop by on my like,
So Did he give you a calculator?
I think I did it wrong.
Oh, yeah, I'll put it on my desk. And after you're done, you're gonna plot these, right? So the first point is 0, comma, -1. The second one is 1, comma, 1. The third one is 2, comma, 3. And then 3, comma, 5. 0, 1, 1, 1, 2, 3, 3, 5. Yeah, well, I've done this a few times already, so that makes it easier for me. No, look, I've done this like 5 times in the last 2 weeks, so it's like, it's easy for me, okay? But normally, yeah, I couldn't do it that fast either, okay? So don't worry. Okay? Do you have all this written down?
I don't, but I have to talk mom.
Hurry up. Hurry up, go ahead. According to this graph, what would the y be if the x is 4? Guys, if the x is 4, what's the y going to be? Just looking at the graph. Good. 7 is right. Right? If we had a big enough piece of graph paper, I could say when the x is 37, what's the y? And you'd be able to find out, right? Just by looking at the graph. Okay?
You know.
Yasmin, why are you taking him away from the lesson?
Why are you taking away from nothing?
Justice, why did you take yourself away from the lesson? All right, so how can I write this equation in symbolic form? In other words, I want to use x instead of these numbers. How can I write the general form of this thing?
What?
2 times 0 minus 1. 2 times 1 minus 1. I want to write the general form using an x instead of these numbers each time. How do I write it?
2x minus 1.
2x minus 1 is correct. Thank you, Elijah. So the output, you take the input, you multiply it by 2 and subtract 1. Okay? Now, once we have that equation, now we can do all sorts of things with it. Okay? We can, if I can give you an x and you can figure out what the y would be, or I could give you a y and you could figure out what the x would be. So for the next problem, they say, in this function rule, what input would be needed to produce an output of 17? The output is the y. So you're just going to plug the 17 in for the y, and now just solve for x. Find out what x would be. All right, let me see if I can find this thing. What is it? No. The y is 17. You multiplied, you put the 17 in for the x. You got to put the 17 in for the y. So the output is 17. Just solve for x now. Okay? Get the x by itself. Not 8. You're close though. All right. 9 is correct. Good. 9 is winner, winner, chicken dinner.
Not what? I got 9. We are talking about.
For this one.
X times 2.
Yeah. You're using the example from the previous one. Using this equation and saying what would the input be if the output was 17. So you replace the y with the 17 and solve for x. That's where you get your, excuse me, the 9.
Okay.
Martin, you don't remember your password by any chance?
Wouldn't it be negative 9?
No,
8, negative 8.
because look, you're going to add 1 to both sides. 18 equals 2x, and divide by 2, it has to be positive, right?
Except it's a fraction, how do I?
All right, can I move down to the next one, guys? Está bien. All right, here's another one. They're giving us the rule. It says it takes an input and change that to x. We're dealing with x and y's here. Let's use x. It takes an input x and converts it into an output y by increasing 1/2 of the input by 10. So the input is which one? The x or the y? X. Now go backwards. It says we're increasing 1/2 of x. How do I write 1/2 of x? Justice. That's homework. She can do that on her own, or she can come to me at lunch.
X over 2.
X over 2. That's one way to do it. Another way would be to just write 1/2 of x. Those are both the same thing, okay? Justice. It says you're increasing this by 10. How do I increase that by 10? That would be increasing it by 5 plus 10. And it's going to be y is equal to that, okay? Or you could put y is equal to x over 2 plus 10, the same thing. So now it's saying, what would the output or the y be if the x is 50? So basically, you're going to plug the 50 in here. What's half of 50?
25.
What's 25 plus 10? 35 is your answer. Right? That's the only way. That's the only answer you'll get if x is equal to 50, right? You believe me? I just made it up. No, I'm just kidding. All right. Now we get to something maybe a little bit more interesting, hopefully. So functions don't always have to work with numbers. They could work with words or colors or any sort of idea, actually, or letters even. So here they're talking about a function that it says in order to be a function, they simply have to return a single input for a given, a single output for any given input, okay? So they're saying here's a function. They're giving us a table. It says it takes as an input a neighborhood child and gives as output the month they were born in. So it says, why can we consider this rule a function? So if it's a function, that means, like Max, there's only one possible answer for him. Evan, there's only one possible answer. Zeke, only one possible answer. Is that right? Can a child have more than one birth month?
No.
No. So every time you put in like Max, it has to give you back January, right? That's why this is a function. Okay? So it says, why can we consider this a rule of function? It's because you can say, because every child can only have one birth month, right? So every time you put Max into this function, it's going to return you January. You can never put in later, put Max in, and it gives you March, right? That can't happen. Right? Whenever you put Max in, it has to give you January. So just right, because each child has only one month they were born in, okay? All right, next question says, what's the output when the input is rosy? How would you translate this to English? What are they really asking you here? What's the output when the input is rosy? In words.
February.
Well, that is the answer, right? The output is February. But what does it mean in English in this example? What does February represent in terms of Rosie?
Birth month.
Her birth month, right?
Oh,
Right? So in English words, when you're saying what's the output when the input is Rosie, the other way of saying that is what month was Rosie born? Right?
we could put February though?
Yeah.
Yeah, just put February.
Right? Because Rosie says February, right? This is just to show you that it's not, it doesn't have to be numbers we're dealing with all the time, okay? It's like, if you understand the concept, it works with that stuff too, okay? Now it says find all inputs that give an output of May. Or in other words, all the children that were born in May. Zeke and Nico, good. Now it says, why does this not violate the definition of a function even though there are two answers? This is where it gets just a tiny, tiny bit tricky.
That's crazy. I use somebody named Zeke as my spur.
I know, that's why I put it in here.
That's crazy. I don't think you knew that.
I did. All right,
Yeah,
I looked into your coconut and I saw Zeke. All right, look. So why is it okay if this is a function if both Zeke and Nico are born in May? Why does that not violate our rule?
That's the.
Yes, good. It's a different input. What were you going to say?
That's the first.
Yeah, just think about it. Let's say you had a room full of kids. Is it unusual if you had two kids that were born in May?
What about, hey, I'm sorry.
But, well, hold on one second. So it's possible to have two kids who were born in the same month, but you can't have one child who was born in 2 different months. That's the difference, okay? All right. So just say it doesn't because it's different inputs. You could say it's different children. Different children could be born in the same month. Now, you said A, because in order to be a function, each input has to have only one possible answer here. So can a child be born in more than 1 month?
No.
No. That's why it's a function, because each child only has one birth, 1 month they were born in. So you just say that. It's a function because each child only has one possible month they were born in. Okay? Now you could have 2 children born in the same month. That's different. That's okay. The way I always say it is like the Y's can repeat, but the X's can't repeat. Not with different answers. Okay? It could repeat with the same answer, so if you had Max in January again, well, that would be okay, because it's still the same output. Okay? All right, one last example. I like this example a lot, actually. So here's a function that represents Charlene going to school one day, okay? And it's given as a function of her distance from school in blocks, that's your y-axis, and the x-axis is how much time she spent walking, okay? So the first question says, how far does Charlene start off from school? Before she starts going anywhere, how far away from school is she?
Wait.
Before she leaves, how far away is she from school? Not 20, a little bit higher. Nope. Each line here represents how many miles. Look, from 0 to 10 is 1, 2, 3, 4, 5 blocks, not miles.
Well, wait, what? 25.
Wait, hold on. There's 5 lines in between 0 and 10.
21.
What's 10 divided by 5?
2.
So each line is 2. So what is that?
2.
22 blocks away from
You
you.
did say miles, Keegan.
Huh?
You did say miles.
I said miles? Oh, okay. Sorry.
I was like, what?
I was wishful thinking because I hate Charlene and I hope she lives farther away. All right, what's her distance from school after she's been walking for 4 minutes? Well, here is your time. Go to 4 minutes. Now, how much is each line worth in terms of the bottom here? Only each one, right? 1, 2, 3, 4, 5. So 4 minutes is right here. And go up to where it intersects the graph. So how far? 14 blocks. Good. Everybody see how I got that?
She fast.
She is fast. That's why I don't like her. She's a fast, loose woman. So here's 4 minutes, and that corresponds with 14, okay? After walking for 6 minutes, in other words here, she stops to look for her subway pass. How long does she stop for? Huh?
Sure she's not on the bike.
No, she's not walking that fast, actually. Look, let's see. She's walking 2 blocks in 1 minute. If it's the short blocks, it's not too bad. Yeah, she's walking a little fast, I guess. Anyhow, it says after 6 minutes, she stops to look for her subway pass. How long does she stop for? 3. How'd you get that? Good. Because what happens when you're standing still? What happens to your distance away? It doesn't change, right? The time is going forward, but your distance isn't changing, meaning you're not moving in the same spot. All right, so 3 minutes. Charlene then walks to a subway station before heading to school on the subway. How many blocks did she walk to the subway? So here's where she starts walking to the subway. Here's where she gets to the subway. How many blocks is that?
That's 2.
2 blocks, good. Now notice, in order to get to the subway, she actually went back the other direction a little bit. You know, she started going farther from school, but you figure like, well, if I go out of my way to get the subway, I'll make up the time, right? So the last one says, how long did it take to get to school once she got on the subway? So she gets on the subway right here. How long does it take her? Huh? Not 5. 4. 1, 2, 3, 4. From 11 to 15, 4 minutes. How long did her entire trip take her? From the time she left home till she got to school?
15.
Yeah, 15. That's where the distance from school is 0 at the bottom there. That's 15. Okay? Excellent. Let me hand out the homework. It's just the same stuff as this.
Yay.
Thank you. Yay. I like it.
What was the name of algebra?
I thought you'd like this. This stuff is to me. This stuff is a little bit more interesting than some of the stuff we've been doing. You know. Well, I mean, to me, it's a little because it's sort of like based on real things in a way.
Yeah.
You know.
I understand. More like situations.
Yeah. So look.
So.
To do the homework, if you look at the first question on the homework, right, it has a table of inputs and outputs. For the first one, it says if the inputs is states and the outputs is capitals, could that be a function? And think of the problem we just did with the birthdays. Can a state have more than one capital?
No.
So is that a function?
Yeah.
Yes. You got the idea? Right? So basically say, you know, if the input can have more than one output, then it's not a function. If it only has one, then it's a function.
What you said? What states and capitals? What?
I said, can a state have more than one capital? Sabian said no. So that means it's a function. Every time you put in New York, you're going to get out Albany, right? So that's how you do those.
Has multiple cities, so it's not a function.
Exactly, absolutely right, yes.
Not all families have pets.
Can a family have more than one pet? So it's not a function. And the last one, it really depends on how you define it.
Families have more than one family.
My family does.
Have more than one family.
Yeah. So I mean, it depends.
They
It's
got
like,
different.
yeah. Like I said, my family does because my parents were divorced when I was young. So I mean, if you go by that definition, then that's not a function. Where are you going? Where you going?
Pack it up.
No way. Could you just make sure I'm staying next to the exit?
Before it gets crowded. Well, like traffic.
What are you expecting to have? A gold rush happening out there?
You never know. I got
Shit, never know.
You got your pan and pan for gold, and your pickaxe to dig
That
for?
picture
You
you
got
laugh. I'm like, oh, somehow pack it up real quick. Like,
Bro, I looked at the computer section. It's like 11:39.
nah, we got how many more?
1 minute.
Yeah, you basically got a minute and a little bit more.
Yo, Mr. Dude's about to give me a assist.
You're gonna give me an assist.
Oh,
Did it go in?
Yes, sir. Hey. Hey, you feel me? Like, I had to give him a little something. Without that jump, you would probably not see me.
I gotta be honest. It intimidates me.
Yeah. Hey, you know, that was my goal last week. Looking forward to coming in the shot.
Oh! You right?
Play safe.
Oh, that's right. I already talked to you. We don't have any brothers and sisters over here, right? Because there is a brother and sister. Everybody thought you were related to them, and I said, no, I don't think he is.
I'm coming at lunch. You can just tell me.
Okay.
Bro,
This thing is mama pop.
It's too far.
Huh?
Mama pop is small.
So Yasmin, I just, because I was videotaping it, I just wanted to make some people, okay? So you can be part of the team.
Hello?
Yeah.